Welcome to the MachineX webinar. So today we are going to discuss about how recommendation systems can drive retail success. Also, we will discuss about how machine learning is driving retail success and what actually retail like domain is. So let's begin with our agenda for today. So today we will go through machine learning in the retail industry, then some top use cases of machine learning in retail. Then we will see how a recommendation system or recommendation engine actually works. Then I have an interesting case study demonstrating the building of recommendation engine. So, before we jump into the main topic, I would like to talk a little bit about our tribe MachineX. So, MachineX is a group of data wizards who love to play with data and create wonders out of it. As you can see on the screen, we are a team of data scientists and engineers with a product mindset who deliver competitive business advantages. So, we love to play with data and like to create wonders out of it. And we are the group of thinkers who love to contribute to the development of artificial intelligence and machine learning. So, and hence we had done some like wonderful things, making intelligent products using machine learning and AI. We usually do internal knowledge sharing sessions as company culture and release them on YouTube so that others can also view and learn from it. Apart from sharing our knowledge about machine learning and artificial intelligence, we are going to release one of our product called Magad. Magad is an intelligent meeting assistant tool which can do a lot of wonders while attending meetings. It will give video recording facility, and along with that, it will give the artificial intelligence powered features like automatic action item generation so that you can like give some MOMs, minutes of meeting, to the person who had not attended the meeting. And also, it will give emotional analysis and the facial detection features and many more. As you might have already imagined, if you have these powers while doing meeting, you can compare yourself with Sherlock Holmes. This is how our Maggot dashboard is looking like for now. Of course, we are going to like add some more and more features to Maggot in coming time. Apart from Maggot, we are working on an intelligent marketing tool called Fisheye. Fisheye is a product or a tool which can help you in finding possible target companies. Like in the screenshot, I had opted for a company in sector artificial intelligence, which located in United States and have an employee size of 0 to 500. Also, we had make an machine learning library in Scala named KSAI. So KSAI is a machine learning plus Scala library. Uh, Before moving to Python, we were like Scala lover here at Noldes. So we think why not a machine learning library in Scala, and we just go through it and make that for ourselves. You can also go through and use KSAI. Just search KSAI on GitHub, and you can also contribute uh, to that library if you are also an Scala lover. So these are few more things we are doing here at Noldes, and we MachineX doing here at Noldes. We have our innovation labs where we are doing some really interesting projects. We regularly do knowledge sharing sessions as in company culture. We regularly contribute to the society of machine learning and artificial intelligence through blogs. You can see all our blogs on like Noldes blogs page. Uh, Also, we have some great and certified AI engineers and machine learning engineers. So this was about our tribe MachineX. Now move to our main agenda, that is machine learning in retail. So we are all aware of the troves of data retail businesses generate on a daily basis. However, this repository of critical data is worthless if it cannot be translated into valuable insights into the customer's mind or market trend. While all the data is being generated and collected, it is not being used efficiently. This paves way for decision makers to employ predictive analytics to drive the best value of all the data gathered, and it can ensure better sales outcome in the near future. Nowadays, data proves to be a powerful pushing force of the industry, or we can say data is like fuel for many of the businesses nowadays. Big companies representing diverse trade ship like to make use of the beneficial value of data. Thus, data has become one of the greatest or important for those willing to take profitable decisions concerning the business. Moreover, through analysis of vast amount of data allows influencing or rather manipulating the customer's decision. Numerous flows of information along with channels of communication are used for this purpose. The retailers manage to analyze data and develop a psychological portrait of a customer to learn his or her sore points. Thereby, a customer tends to be easily influenced by the tricks developed by the retailers by using this data analysis and machine learning by predicting his behavior. So these are some like interesting use cases of machine learning in retail sector. The first one is market basket analysis. So it may be regarded as a traditional tool of data analysis in retail. The retailers have been making a profit out of it for years. This process mainly depend on the organization of a considerable amount of data collected by customers' transaction. Future decisions and choice may be predicted on a large scale by this tool. Knowledge of the present item in the basket along with all likes, dislikes, and the previews are beneficial for a retailer in the spares of layout and like organization. So the analysis is usually conducted by a rule mining algorithm. Beforehand, the data undertake transformation from data frame format to simple transactions. A simply tailored function accepts the data, splits it according to the to like some differentiating factors, and deletes the useless data. And then this data is our input. On its basis, the association link between the product are built. It becomes possible due to the association rule application, and also the insight information largely contribute to the improvement of the development strategies and marketing techniques of the retailer. So the next one is warranty analytics. Warranty analytics entered the sphere of retail as a tool of warranty claims monitoring, detection of fraudulent activity, reducing cost and increasing the quality of your means sales and your retail market. So the data is transformed into actionable real time plans, insights, and recommendations via segmentation analysis, or we can like segmentation analysis. Okay, so the method of detecting are quite complicated as far as they deal with intensive data flows. They concentrate on the detecting anomalies in the warranty claims. Powerful internet data platforms speed up the analysis process of a significant amount of warranty claims. This is an excellent chance for retailers to turn warranty challenges into actionable intelligence. Next one is price optimization. So having the right price for both the customer and the retailers is a significant advantage brought by the optimization mechanisms. So the price formation process depends only not only on the cost to produce an item, but on a wallet of a typical customer and the competitors offers. The tools for data analysis bring this issue to a new level of its approaching. Price optimization tools include numerous online tricks as well as secret customer approach. The data gained from the multi-channel sources define the flexibility of prices, taking into consideration the location and individual buying attitude of a customer, seasoning and the customers pricing. The computation of a extreme in values along with frequency tables is a appropriate instrument to make the variable evaluation and we can say perfect distributions for the predictors and the profit response. The algorithm presuppose customer segmentation to define the response to change in prices. Thus, we can say the cost that meet corporate goals may be determined. So next one is inventory management. We all are aware about inventory management. So inventory as it is concerns stocking goods for their future use. In this, in its turn, it refers to stocking goods in order to use them in times of crisis. The retailers aim to provide a proper product at a right time, in a proper condition, or we can say at a proper place. At this, in this regard, the stock and supply chains are deeply analyzed. Powerful machine learning algorithms and data analysis platform detect patterns, correlation among the elements and supply chains. Via constantly adjusting and developing parameters and value, the algorithm defines the optimal stock and inventory strategies. The analysts spot the pattern of high demand and develop strategies for emerging sales trend, optimize delivery, and manage the stock implementation, like implementing the data received. This one is interesting when I was going through like some of the use cases of machine learning in retail. So that is location of new stores for detail. It was also a new use case for me also when I was going through it. So data science proves to be extremely efficient about the issues of new stores location. Usually, to make such a decision, a great deal of data analysis is to be done. The algorithm is simple, though very efficient. The analysts explore the online customers' data, paying great attention to the demographic factor, the coincidences like in zip codes and location give a basis for understanding the potential of the market. Also, special settings concern the location of other shops are taken into account, as well as that the retailer's network analysis is performed. The algorithm find the solution by connection all these point. The retailers easily adds this data to his platform to enrich the analysis opportunity for another sphere of its activity. So the another use cases is customer segment sentiment analysis. So customer sentiment analysis is not a brand new tool in this industry, although it is using by different industries also. However, since the active implementation of data science, it has become less expensive and time consuming. Nowadays, the use of focus groups and customer polls is no longer needed. Machine learning algorithms provide the basis for sentiment analysis. The analysts can perform the brand customer segment sentiment analysis by data received from social networks and online services feedback. Social media sources are readily available, so this is why it is much easier to implement analytics on social platforms. Sentiment analytics uses languages processing to track words bearing a positive or negative attitude of a customer. This feedback become a background for services improvement. The analyst performs sentiment analysis on the basis of natural language processing, text analysis to extract defining positive, neutral, or negative sentiments. The algorithms go through all the meaningful layer of speech. All the spotted sentiments become like belong to certain category or bucket or the degree. And the output is a sentiment rating is one of the category mentioned above, like in this diagram, and like and the overall sentiment of the text. So these were the use cases, like some different use cases from our agenda. So let's come to our main agenda for today, and that is recommendation system. So in today's world, every customer is faced with a multiple choices. For example, if I am looking for a book to read without any specific idea of what I want. There is a wide range of possibilities how my search might pan out. I might waste a lot of time browsing around on internet, trawling through various sites hoping to strike gold. I might look for recommendations from other people. But if there was a site or application which could recommend me books based on what I have read previously, that would be a massive help. Instead of wasting time on various sites, I could just log in and there could be 10 recommendations, like recommended books tailored to my taste. This is what recommendation engine do, and their power is belonged like harsh by most businesses these days, from Amazon to Netflix, Google to Goodreads. Recommendation engines are one of the most widely used application of machine learning techniques. So the main one of the main question is how we can how we can recommend items to the user. So there are two things. We can recommend items to a user which are most popular among the users. Second, we can divide the users into multiple segments based on their preferences or users features, and recommend items to them based on the segment they belong to. But both of these points or these methods have their drawbacks. In the first case, the most popular items would be same for each user. So everybody will see the same recommendations. While in the second case, as the number of user increases, the number of features will also increase. So classifying the users into various segments will be a like hectic, or I can say very difficult task. So the main problem here is that we are unable to tailor recommendations based on the specific interest of the users. It's like Amazon is recommending you to buy a laptop just because it's being bought by a majority of shoppers. But thankfully, Amazon does not recommend products using the above mentioned approach. They use some personalized methods which help them in recommending products more accurately. So let's now focus how a recommendation engine work by going through few steps which involved in recommendation system. So first one is data collection. So this is the first and most crucial step for building a recommendation engine. The data can be collected by two means, explicitly and implicitly. Explicit data is information that is provided intentionally. For example, input from the users such as movie rating, uh, like some movie rating, or we can see that in our next one. So where we were, okay. So implicit data is the information that is not provided intentionally, but gathered from available data streams like search history, clicks, and the order history. So we can see both of them in like our next slide. So this is our uh, like Amazon example, how they are recommended or collecting data from us. So uh, this is the order history of a user is recorded by Amazon, which is an example of implicit mode of data collection. So our next important step is data storage. The amount of data dictates how good the recommendation of the model can get. For example, in a movie recommendation system, the more ratings user give to the movies, the better the recommendation get for the users. So the type of data plays an important role in deciding the type of the storage that has been to used. This type of storage could include a standard SQL database or a no SQL database or some kind of object storage. So after collecting like data and storing the data, we have to filter it as to extract relevant information required to make the final recommendations. So there are various algorithms that like helps us to make the filtration process easier. So let's go through them. But before going through them, let's see a few example. So on our left there is an Amazon recommending for you, and on the right it's Netflix recommending like something it's happening. So in both of these example, Amazon is recommending some products to you, and Netflix is leveraging this recommendation engines to like giving you top movies according to your taste or according to your preferences. So recommendation engines usually consist of two things. First is user, and the second is items. So here on the left there are users, and the right we I have taken example of Netflix. uh, it's we match down match the columns in our school time. So this is how recommendation system work. We match the users preferences with the movies, and we match the preferences of particular user with their preferences or their rating, and whatever data we collected from uh, the activity of user. So implementing a and recommendation system. Now let's discuss about it. But first, in this tab thing, we can easily see the trending movies recommended by Netflix. So when a user when we don't have data uh, of a particular user, or a new user comes in, and uh, like uh, we have to recommend something to them. So this is how Netflix is doing it. So Netflix is giving all the movies which are in trend by like noticing the user ratings given by different users, and the comments and everything a user is giving to the movies, and how many number of times these movies are watched by the users. So this is called the trending, as we all know. So now see how to implementing implementations of an recommendation system. So there are a few things. Like first is our content based, and second is our collaborative filtering. So content based is actually on the left side. Let's see content based first. So the content based is we have a user who likes to read. Let me give you an Let's take out the pointer. So here we have an user who likes to read this type of book or any other document. So we will find something related to this, similar to this article or the book. It can be a same author, it can be a same publisher, or the content in both of these article or novel or book. So this is how content based is actually work. And this is our collaborating filtering. As we can see, there are two similar users. So this is the book. These are the books both users used to read, or this can be anything like movie, book, article, or any post. So we can simply use this data for recommendation. So uh, we can see that both of these users are reading these type of articles. So and the girl in the left is also read this book, so we can recommend this book to him also, because in the previous data or previous history of data, we noticed that both of these users have like same kind of like taste about um, reading things or watching movies. So first let's like talk about content based filtering. So content okay, so for example, if a person has liked the movie Inception, then this algorithm will recommend movies that falls under the same genre. But how does the algorithm understand which genre to pick and recommend movies from? Consider the example of the Netflix. They save all the information related to each user in a vector form. This vector contains the past behavior of the user, that is, the movie liked or disliked by the user and the rating given by them. This vector is known as profile vector, and all the information related to the movie is stored in another vector that is called item vector. So item vector contain all the detail of each movie, like genre, cast, and the director of the movie. So the content-based filtering algorithm find the cosine of the angle between the profile vector and item vector. So cosine similarity, okay, I have some example for you. So I will just uh, it will be more as understanding through this example. So we have these two text A and text B. Can you guys please tell me, is there is any similarity between these two texts? Is these texts are similar in which mean and how? Okay, someone is saying that both of the texts contain same words. You are correct. Okay, so uh, so Rahul is correct in his answer. These words or sentences contain similar words. So let's draw a distance between these two vectors or making two vectors. So a lot of people feared when we say about the vectors. I was also not like these vectors a lot, but when I entered the data science world, I have to learn and love these kind of things. So uh, I have two axes here, or the two dimensions. First is Paris and the second is London. Can anyone tell me why I have these two axes only? Why not a third dimension or third axis? I'm waiting, guys. Can I have your answer? Okay, Abhishek is saying that we might not need them. Please, can you be more specific about it? Okay, let me tell you. So here we have two text A and text B. It contains two common words only, like London. First one contain London two times, Paris one time, and the second one contain London one time and Paris two time. That's why we have two axes or two dimensions here. If we have the third word common between these two texts, or the three, four, or five, fifth thing, so we have to take third, fourth, and fifth dimension or the axis. So we can just draw the vectors of these points from 0 0 to 1 2 for the text B, and for text A to 0 0 to 1 according to their frequency of word. So then we have to calculate something called like uh, Euclidean distance. So Euclidean distance is like similar items which lie in the close proximity to each other if plotted in an n dimension shape. So we can calculate the distance between the item based on that distance, recommend item to the user, like the formula of the Euclidean distance, and we all know the formula, so I didn't like mention it here. So there are many other things also like Pearson correlations and different things. So a major drawback of this algorithm is that it is limited to recommending items that are of the same type. It will never recommend products which the user has not bought or liked in the past. So if a user has watched or liked only action movies in the past, the system will recommend only action movies. So it is a very narrow way of building an engine. To improve these type of system, we need an algorithm or an like algorithm that can recommend items not just based on the content, but the behavior of user as well. So here a different algorithm comes, that is collaborating, like collaborative filtering. So let's understand this with the example too. So if a person A likes three movies, say uh, Interstellar, Inception, and predestination, okay, and the person B likes Inception, Predestination, and the Prestige, then they have almost similar interest. We can say that the person certainly that A should like the Prestige and B should like Interstellar. The collaborative filtering algorithm uses user behavior for recommending items. This is one of the most commonly used algorithm in industry, as it is not dependent on any additional information. There are different type of collaborating filtering techniques, and let's look on them. So the first one is user collaborating filtering. This algorithm first finds similarity between users. Based on this similarity score, it then pick out the most similar users and recommend products which these similar users have liked or bought previously. In terms of our movie example from earlier, this algorithm finds the similarity between each user based on the rating they have previously given to different movies. The prediction of an item for a user U is calculated by computing the weighted sum of the user rating given by other user for an like to an item I. So now we have the rating for users in profile vector, when we calculate our prediction PU. So we can do some more steps, like for predicting we need the similarity between the user U and V if we have these users, and we make use of Pearson correlation, as I already told you, and the prediction can be calculated using the similarity value. So the algorithm first of all calculate the similarity between each user, and then based on each similarity calculates the prediction. So user having higher correlation will tend to be the similar. So in this the this algorithm is quite time consuming, as it involves lot of calculating the similarity for each user and then calculating prediction for each similarity score. So one way of handling this problem is to select only a few users neighbors instead of make predictions. Instead of making predictions for all similarity values, we choose only few similarity values. So next one is item collaborative filtering. So in this algorithm, we compute the similarity between each pair of items. So in our case, we will find similarity between each movie pairs, and based on that, we will recommend similar movies which are likely liked by the user in the past. This algorithm works similar to user collaborating or collaborative filtering with a little bit of change. Instead of taking the weighted sum of rating of user neighbor, we take the weighted sum of ratings of item neighbors, and the prediction is given by some certain formulas. And then we make a matrix according to like one is the user metrics and other is the like uh, name of the movies. Okay, so let's move. So these were the type of like our collaborative filtering, and we have discussed about content based and like collaborative filtering. So let's have a small demo. So here I had like make my like demo on. I'm using Jupyter Notebook. So Jupyter Notebook is like popular among most of the data scientists to make projects. So the problem statement is in this data challenge, we are building like collaborating filtering model for recommending like product items. So the steps below aim to recommend users like their top 10 items to place in their basket. So the final output will be a CSV file in the output folder and like function that search for a recommendation list based on a specific user. So here we will have the input as an user or the customer ID of that user, and we will return the ranked list of the items or the products that the user is most likely to want to put in his basket. So suppose when you open your Amazon page or your Amazon dashboard, there are a number of products which are recommended by Amazon for you, that may be liked by you, or you want to add them in your cart. So here I imported my modules like pandas and numpy for data manipulation, and Tunicreate for performing model selection and evaluation. So I have here I had like mentioned everything above the cells, because if you guys like want this notebook or this presentation, you can simply like mail me. I think my mail ID is already shared with you all through this platform GoToWebinar. So you can simply mail me all your questions and like request for this presentation or the notebook. So here I had like import pandas at PD as an object PD, and NumPy at the time, and Theory create for creating our model or selecting our model for uh, like uh, for our recommendation engine. And I had used scikit-learn library to split my data set into train and test. Like we all familiar with splitting the data set into two parts, for first for the training phase and the second for the testing phase. So next we will like load our data set. I had load my, there are two data set. First is recommend one CSV file consists of list of 1,000 customers ID to recommend as output. And second one is consist of user transitions, all the transition user had made in his past uh, history or like actions. So when I print this customer shape or the customer file shape, so it is like I have thousands customer data or their IDs, and when I like print the transitions CSV, so it is like I have 62, like nearly 62,000 of transition data. So now the most important step in doing any data science project is data preparation, or we can say pre-processing of data. So our goal here is to break down each list of items into the products column into rows and count the number of products bought by user. So guys, I have I didn't have a lot of time, so I'm going a little bit fast here, and I can send you this file, and I have also a blog written on this this project, so I will also share that blog with you guys. So here I split my product items by using that apply method, and here is the output. I have customer IDs and number of like products. So next, I have organized a like table into data frame with customer ID and single product ID and purchase count, how many times that product is like purchased. So this is my customer ID, and this is my product ID, and this is how many times a customer has purchased that particular product. Now let's create data with user like item and target field. So this table will be an input for modeling later. So in this case, our user is customer ID, like product ID and purchase count. So this is how I had like did this task. And when I like see head of my data, so this is how it's look like. So this is my customer ID, product ID, and purchase count, and it is in like more structured way. Like it is now in structured way. So let's so here is an interesting thing to see. So I had created dummy. So dummy for like making whether a customer bought that item or not. So if one buys an item, then purchase dummy as like marked as one. So why create a dummy instead of normalizing it? You can ask this. So normalizing the purchase count, say by each users, would not work because customers may have different buying frequency, do not have the same taste. So that's why I had created a dummy for that purpose. And I had also like used normalize. So to do this, we normalize like purchase frequency of each item across users by like first creating a user item matrix as follow. So you can see this output here. So when I like see the shape of my this normalized matrix, so this is what my shape of normalized matrix is. So like move forward for the modeling part. So we are creating a table for input and like as an input to our modeling part. So this is how like I'm giving my like column a name, scaled purchase frequency, because I had scaled it to a similar range of value. So this is our new data set or training data set looks like. I have same customer ID, product ID, and now I haven't scaled purchase frequency. So our model can be more accurate in recommending things to the user. So we are like defining a function for normalized data. So this is same as the previous one. So we can like normalize their purchase history from 0 to 1. So 0 like with 1 being most number of purchases for an item, and 0 count for the like 0 for the 0. So now I have used like scikit-learn for like splitting my training and testing data set. So I am like splitting my training and testing into 80 to 20% like ratio. So guys, I am like running out of the time. So now let's see the main puzzle. So this is my baseline model. So before running a more complicated approach such as collaborative filtering, I am like seeing the baseline model. So here I had like made an popularity model, uh, and like I had like trained it on my data set. This is my user to recommend, and I had displayed it as an output. Then I had made an like different type of approaches like Pearson like correlation and the cosine one, and I just trained my model to recommend the things. And using the dummy data too, I had like this is my output of model, like predicting model, or we can say. So I had used this many approaches to make my recommendation engine like Pearson similarity. So this is the formula of Pearson similarity. So I had also like used Pearson similarity method. So we have to simply like give the parameter of model to Pearson, and give our target variable, that is purchase count. So here is how our output is look like. So let me like take you through to the output, and this is my RMSE, like the score which is uh, achieved by my recommendation model. So let me go through you to the output. So when I completed like making my model, so it is uh, very hectic task to like select which model is like good for my recommendation engine. So based on RMSE, I can like select which one is like more accurate, or which I can work with. So based on the RMSE score, I selected my model, and my final output I can like create with simply TC. tc.itemsimilarity recommender.create. So here I am like creating my output file or the recommending things to a particular user. Also we can see like here this is my output file. So for a particular customer we are like predicting or recommending number of products, like product with the id 226 to 247 to 30. And what will happen with application, this application is whenever like suppose a customer with id 21, so whenever he logged in your like product or the website, so you can like you have the previous transition of that particular user or the customer, so you can simply recommend these number of products to him, like product number 226 or 247. Suppose a person is like in your previous transaction a person is like searching for like vehicle, four-wheeler vehicle, so you can like uh, recommend him a car or something like which he was searching previously. And suppose any other another customer comes with a customer id 16, so you can give this number of like products to him. So so these customers were like in the same segment, so it is like giving them same number of recommendation products. So in this exercise we were like able to traverse a step by step process for making recommendations to customer. We used collaborating filtering approaches with cosine and pearson measure and compare the models with our baseline popularity model. We also prepared three data set or the sets of data that include regular buying count, a buying dummy, as well as normalized purchase frequency as our target variable. Using RMSE, like precision and recall, we evaluate our models or our best model and observe the impact of personalization. Finally, we selected the cosine approach in our dummy purchase data, and we like simply like take our output from that model. So this is how you can like make a recommendation system. So if you have any question, just like you can write to me, or you can like connect, stay in touch with us with id hello@knowledge.com, or you can simply like join us on Twitter. So thank you guys for joining this webinar. uh, I hope you will like this webinar, and I am eagerly like waiting for your feedback. So do give feedbacks. You can send these feedbacks to my mail address. So feedbacks are the only things which can help me in improving myself. And like whatever things you want to like see in the our future webinars, you can also like uh, suggest us the topics or any particular technology or in machine learning and artificial intelligence. So thank you guys for joining us.